Today we're going to talk about the normal distribution. The normal distribution is just a special type of probability distribution. So let's just recall a little bit about probability distributions. If we have an experiment, then the random variable x tells us all of the outcomes of this experiment. And the probability distribution tells us the probabilities of each of these outcomes. In the case of a discrete random variable, our probability distribution looks like a histogram. And in the case of a continuous random variable, our probability distribution looks like a smooth curve. And so one type of continuous probability distribution, one special type, the one that probably comes up the most in applications, is what's called the normal distribution, also referred to as the bell-shaped curve because it has a bell shape. And well, a few properties of this normal distribution. First off, it is centered and symmetric about the mean mu. So right here in the middle is the mean. Also, the total area under the curve is equal to 1, which makes sense if we think about what a probability distribution tells us. Well, if we take all of the probabilities of all of the outcomes in any particular experiment, so all these distinct outcomes, if we add up the probabilities, well, we should get a total of 1, or 100%. And so same thing here, the total area under this curve, which represents the total probabilities of all of these data items being chosen, they should have a total of 1. Also, the last property is that a normal distribution is completely defined by its mean mu and its standard deviation sigma. So for any mu and sigma that you can think of, there is a normal distribution associated with it. And so at the top of this page, we have just a couple of examples of two different normal distributions. Notice they are both bell-shaped, but they have kind of different shapes. The first one is a little flatter, it's more spread out, and that means that it has a larger standard deviation. Whereas this other normal distribution, the skinnier one, the data values are less spread out. They're closer to the mean. And so this one has a smaller standard deviation. And no matter what kind of standard deviation we have, no matter what the mean is, if it's a normal distribution, it's going to follow what's called the empirical rule, or the 68-95-99.7 rule, which tells us, first of all, that approximately 68% of the data items fall within one standard deviation of the mean. All right, so what does this mean? Well, in our curve here, the mean mu is right in the middle, and if I go just one standard deviation above mu, so this would be mu plus one standard deviation, so mu plus sigma. And if I go one standard deviation below the mean, which would be mu minus sigma, well then, in this region here, what we get is 68% of all of our data items, or if you like, 68% of the total area under the curve lies within this region. All right, so what we can say is 68% of the data items fall within one standard deviation of the mean, or if you like, we could say between mu minus sigma and mu plus sigma. Similarly, if we go out, say, 2 standard deviations, so now I'm going to go one more standard deviation to the right, which would be mu plus, well, now we've added 2 standard deviations, so this would be 2 sigma. Or if I were to go to the left, one more standard deviation, now I would be subtracting 2 standard deviations, so mu minus 2 sigma. Well, in this case, we get even more of the data items. We actually get 95% of them. So 95% of the data items fall within 2 standard deviations of the mean, or if you like, between mu minus 2 sigma and mu plus 2 sigma. And then finally, if we go out 3 standard deviations in either direction, so this one here is mu plus 3 sigma, because now we've traveled 3 standard deviations beyond the mean. This guy over here is mu minus 3 sigma. Well, then in this case, we actually get almost all of the data items. In fact, we get 99.7% of the data items are going to fall within 3 standard deviations of the mean, or if you like, between mu minus 3 sigma and mu plus 3 sigma. All right, now let's take a look at an example. So we're told that the heights of men in a town are normally distributed with a mean of 70 inches and a standard deviation of 3 inches. And part A, we're asked to draw this normal curve, and we're going to label the horizontal axis. So here's our normal curve. In the middle is our mean, which we said is 70 inches. Okay. And now I'm going to label one standard deviation both above and below the mean. So if I go 1 standard deviation above the mean, well, that's going to be 70 inches plus our standard deviation of 3 inches for a total of 73. And if I go 1 standard deviation below the mean, well, this time I would do 70 minus 3, giving us 67. If we go 2 standard deviations above the mean, I just need to add 1 more standard deviation, which would bring us to 76. And if I go 1 more standard deviation below the mean, I would just subtract another standard deviation, bringing us to 64. And then finally, let's do 3 standard deviations, either above or below. So above, if I add 1 more standard deviation, I would get 79. And below, if I subtract 1 more standard deviation, I would get 61. All right. And now to answer part B, what percentage of men are between 67 and 73 inches tall? Well, that's going to be this region here. This is within 1 standard deviation of the mean, which we know by the empirical rule is 68%. And what percentage of men are between 70 and 73 inches tall? Well, that's going to be this region right in here, right? Which notice is half of that 68%. By the symmetry of this curve, this region over here accounts for half of that total 68%. So half of 68%, that would be 68% divided by 2, which gives us 34%. And then finally, what percentage of men are shorter than 70 inches? Well, that would be, if I were to sketch that region, shorter than 70 inches would be everyone over here to the left of 70. And well, what percentage of the curve is shaded here? Well, because the total area is 1 or 100%, and again by the symmetry, to the left of 70 is going to account for half of the total area. So half of 100% would be 50%. And there we go.